Naples Tower, this is helicopter 357 Lima Hotel requesting Humber taxi to spot Charlie with Alpha.
Hey everybody, welcome back to the Skunk Works. This is part 8 of the official beginner's guide to the Blade SR, and this is Rob. Today we're going to be talking about what's called idle up mode, or what's also referred to as stunt mode, and we're going to be talking about why that exists, why it's there, what it's used for, and why you'd want to know about it. You really do want to know about this if you plan on taking up this hobby. You plan on advancing with it and going further with it, and you eventually want to do aerobatic and 3D flight. You will want to know about idle up or stunt mode. So that's what we're going to cover. First thing I'm going to do is just give you, I'm going to show you what's actually happening with stunt mode when you switch your transmitter into the stunt mode or idle up mode. And I'm going to show you what happens here, the difference with the helicopter, and then I'm going to I've prepared a few graphs, some things I drew up on the computer to give you a graphical representation that will give you an even better understanding of what's happening in the idle up or quote stunt mode. Okay, let me first start out by showing you what's going on in your normal mode. You're in your normal mode when this switch here in your transmitter. You're in your normal mode when this switch is back on your transmitter. And normally, you just watch the edge of the blade here. I want to keep my fly bar as straight as possible to do this. If you watch the edge of that blade, as I move the throttle stick, it's in its full down position right now, and notice that the blades are right around 0 pitch right here, 0 degrees pitch. As I move it up, you just get more positive pitch as you move the stick up. As you move it down, it goes back to 0 degrees. All right. Okay, now in your idle up mode, or stunt mode, we're going to flip the switch forward. Now notice that right away, the blades actually go to a slightly negative pitch. They do have a negative pitch to them, and the stick is in full down mode. But let's start right around mid-stick here. All right, at mid-stick, your blades are right at around 0 degrees pitch. There should be right around there with the SR, right around that area. All right, when you move the throttle up from the mid-stick position, your blades pitch positively. All right, back to mid-stick. Now, if you move it down, you see the blade gets some negative pitch to it there. All right, so mid-stick, 0 degrees pitch, full up stick, positive pitch, and down is negative pitch. Okay, so why is it doing that? All right, what's the reason for the negative pitch when we go all the way down with the stick like that? Well, in idle up mode, and I will be showing you a graphical representation of this in just a moment. In idle up mode, your throttle is always up, first of all. Your throttle is always at flight RPMs. You can't just go like this and shut it down and it will stop spinning. You actually have to take off you have to put this back in normal mode for that to happen. But in idle up mode, your throttle's always up at flight RPM. So the negative pitch, instead of your thrust being down this way, your thrust is now up this way. So you've got your airflow coming from the bottom of the rotor disc, exiting out through the top. Why is that? Well, that's so that, I'm going to zoom out here, get a better view. That's so that you can fly the helicopter inverted, like so. You got your rotor wash, your airflow going down this way through the rotor disc. You can hover and perform the upside down aerobatic or 3D maneuvers and so forth. So that's what idle up does when you're in the idle up mode. You have your positive and negative pitch, and also your throttle is always at flight RPM, so you can't just shut it down. So what I want to do now is I want to go ahead and I'm going to give you a graphical representation of that. So let's look at it here. Okay, this graph represents your what's called the pitch curve. And don't be intimidated by this because I'm going to thoroughly explain it. Just hang with me here. This is our pitch curve essentially for what would be the idle up mode or the stunt mode. All right, the graph going from all the way to the left to all the way to the right, that represents your stick position. In other words, all the way to the left would be full down stick, all the way to the right would be full up stick. So that's left to right. Okay, so starting from the bottom, the horizontal line on the bottom, that would be all the way to your negative pitch or your most negative pitch, and all the way up to the top represents your full positive pitch. And the green line in the middle represents mid-stick or zero pitch. So you can see from the graph here, starting at mid-stick, if you're, that's where your stick is, you're going to be at 0 degrees pitch. If you move it up from the mid-stick position, you're going to get positive pitch. If you move it down from the mid-stick position, you're going to get negative pitch. And that's pretty much called that's a linear pitch curve. More up stick you give it, the more positive pitch you get. The more down stick you give it, the more negative pitch you get. Okay, so that's the pitch aspect of the idle up mode. Now we want to cover the throttle aspect of the idle up mode. And I have a graph that I'm going to show you for that as well. Okay, what you're seeing now, this represents the throttle curve. And I want to explain this graph to you. Once again, going from left to right, all the way to the left represents your stick being in the full down position, all the way to the right represents your stick being in the full up position, and right about in the middle would be your mid-stick position. The blue line, that blue kind of V-shaped line there, that represents your throttle curve. In other words, from the bottom of the graph, the bottom would be zero throttle or zero motor output. The top of the graph